So we'll do anti-cheat in a bit more detail, because I think it will make more sense then. But you said there that it's kind of the first product. So the
Yeah.
first product from what? So what? So you've started Capsule AI.
Yeah.
Anti-cheat has come out of that, but what's the overall aim of Capsule?
I think the overall aim, data science is just really difficult. I maybe I'll step back from that a bit. I think it's really difficult to make it work in a productive way for whatever your needs are. It's not too difficult to just like take a data set and then take a model and then try and do some stuff with that. And like Kaggle, has simplified that model like famously, or simplified that whole process. So people can really engage with that part of it. And I think if you just engage with that part of it, you can feel as though data science is really productive. But something that is hidden in that is just how difficult it is to have the setup like that you need to do that. Getting your data, or finding data in the first place, finding some way of like cleaning your data and specifying your problem, working out what exactly your problem is and what amenable solutions there are to it, whether you want to go down the route of like doing manual embeddings, or whether you want to go down the route of just like chucking everything into a black box. And then actually you've got a model, you've got some kind of model architecture, maybe you've trained it. How do you make that process repeatable? How do you make that process reliable? How do you then do it at scale? So basically the ops of a model. And this is something that people are aware of, that this is like a huge problem. And there are lots of companies actually that are around and about trying to help businesses with these issues. But anyway, like it's just a huge pain in the ass, basically. And my kind of view on it became at Napier specifically that, so we were kind of like a data science team in Napier. I was in the data science team, and we were very siloed, and for understandable reasons. Like, I don't think the intent was there to have everybody be siloed and not communicating. But if we think about what communication requires, you need that kind of like an empathy of understanding of what other people are working on. And I think as a member of the data science team who has some kind of engineering awareness, it's not too difficult to have empathy for the engineering side of the business. But if you're perhaps an engineer or another part of the business who has not necessarily a large awareness of like what goes on in data science, it's way more difficult to actually like understand the needs and requirements. So there just ends up being friction. And this is just like one part, I think, how like beyond all the operationalizing of data science, this is just in yet another way in which it like becomes difficult to manifest productivity from it. So it kind of like, the thought basically was, it'd be nice if you just could centralize all of this. Like, what you could just get a team and they could just be really, really good at data science. They could just be really, really good at data science. And the thing you need for that, the way to make that work, in my opinion, is that you need to understand the interface of that to then business requirements. So instead of every business having a data science team and finding it very difficult to make that work for them, just have a data science team in one place, and then get really good at understanding business problems and translating between what they want in the language that they want it, and what you can offer on the data science side, so that you can actually like you can own these operational like solutions, make that really work for yourself. And then when a business has a problem, anti-cheat, for example, look into that business, that sector, ask, okay, how do they talk about it? What are the problems that they have? What are the like technical specifics of how like games work? We can do data science on this. How are we going to broadcast that to them? How are we going to effect a solution for them? But we'll own the data science part completely, and then we'll act as the interface. So that's kind of like that's the core idea of it. What if you could own data science and then own all of that complexity and get really good at offering that as a service? But in a way that businesses don't recognize it as offering it as a service. You're just you're just talking to them about their problems.
Yeah. So there's like a domain boundary from the business into a black box that makes all the magic happen.
Yes,
massively simplified.
Yes.
I think it's a really good approach, because having spent many decades working with, not that many actually, a couple of decades working with organizations that have an engineering function, and some of them were engineering organizations. I think people struggle with engineering, to kind of bring it into an organization and make it run effectively, because you're crossing a barrier into a different world, and people will just kind of, I don't know anything about that, and it gets really difficult to make an engineering function work effectively. And the thing that I like about kind of the AI ML and the data world is that we talk about science a lot more. And again, it's a complete differentiation between engineering and science. And I think for organizations then to take on a completely different way of thinking and understanding is exceptionally challenging. So I can completely see why, A, I think the time is right, but B, why your approach and your offering makes sense. The last thing I would want to do if I started an organization would be to try and figure out what a good data scientist look like, because I would have no clue on how to interview them, let alone how to integrate them into the business effectively. So that makes complete sense.
Yeah. I think it's just one of those things where you encounter subtle problems all of the time of a sort that are just kind of like hard to deal with in the ML space, that is. And unless you're really on the lookout for them, it's just easy to end up doing, the wrong thing, or, it's just so easy to overfit your model, basically. And it takes a lot of effort and thought to stand back and, analyze these situations. And I completely agree with you. I mean, there's lots of, I don't feel like I'm in a great place to necessarily hire a marketer or a head of sales, because that's not my domain specialization. I started a business, so I guess I have that responsibility. I'm going to have to understand how to, or have an idea in mind of how I want this to go at some point. But yeah, it's just I guess maybe I should also say that if I was starting a business that wasn't in data science, I also wouldn't want to hire a data scientist. I think I would find that very difficult.
Yeah. Do you think that where the industry is now, because obviously there's the explosion with kind of ChatGPT, and now everybody's an AI expert and everybody's trying to be a forerunner, apart from the people who are actually developing this, who are talking very sensibly and saying, we're not in a position to do this now. Do you think often the bridge, I think, into the data world is through the engineering world? It's kind of two parts of the question. Do you think the engineering world has a clear view of how it interfaces with the data world, the AI, ML, data science world? And the second part would be, do you think the reverse is true, that there's a view of how to operate with an engineering team? Or do you think it's really even still too early to be kind of talking about that sensibly?
I definitely don't think it's too early to start talking about that sensibly, because I think those discussions need to be had. And in a lot of ways, you only work out what you need when you try. So it's definitely the right time to talk about those things. But as to where it stands, I think it's very, very difficult. We kind of, in our 3-person setup, we do this at a very small scale, where we do engineering work and we do data science work, and we ask what are the relationships between these. And I think this might be my bias, is I have more of an engineering mentality than a data science mentality. So this might be my bias just coming out in this, but I definitely think my view is that you get a sense of how things fit together when you define APIs. And that's a really kind of engineering style mindset in my view, but I think it applies to data science just as well as everything else. And I guess what I would say, as a more pithy way of describing that point, is just code is code. Data science code is code, and it has the responsibilities around APIs and how it wants to interface with things and how it wants to express itself just as much as any other code does. It just wants to work in a different way. You have these large flows of data through this, and you very often come across patterns of pipelines of transformations and stuff like that. So these are commonalities to it, whereas a commonality in building a language would be implementing a parser. But these are all different bits and pieces, and they're going to need to fit together at some point. So I think my view on it is that there needs to be an engineering mentality in everything which is going to be engineered together.
Yep.
But I don't want to just put it all on the data science. I think there also needs to be a recognition that there needs to be a lot of basically help from engineering, people in whatever organizations. There needs to be a lot of help for the data scientists to understand exactly what it is that is being constructed, because that's definitely one of the most complex things. Like when you come to the question of like, it's a classic engineering thing. I want to abstract something. It's really hard for me to deal with all of these individual specialized models. I would really love an abstraction. Okay, well, I should be able to abstract over models. It seems reasonable. Like what is a model? I work with a very simple definition. A model is just something that predicts. Doesn't even necessarily need to be trained. Okay, fine. So go and implement that. And then when you as an engineer, when you confront that, and then you confront the variety of models and the variety of ways in which they want to work and how they want to consume data, and also the variety of implementations and the work that's been put into implementations by several different people with different kinds of expertise, especially in the Python ecosystem, you find that you're confronting like what is essentially a huge mess. And that's not to denigrate the work that anybody's done, but rather that it's just so complex that it is confronting with what you need to do. So you need a lot of empathy, I think. You need a lot of like and you need to be able to like step up and help with that, because I guess, and maybe I'm winding my way to actually a more concise answer to this question, and both questions perhaps, which is that this is still so new, and I think that the patterns with which we approach it are still not clear to everybody. So those patterns should be clarified, and it's like a collective effort to go and clarify what those patterns of development are, so that we can say, like if I'm doing some code and I'm doing some engineering and I'm like, oh, I've got this problem, I'll just use a state machine, to do this. That's fine. It's very easy for me to think about it in that way. But data science doesn't, I think, have that benefit as of being so new. So you need to collectively work with the experts to understand where the boundaries lie on this thing. And then I think it's a task definitely for people with expertise in defining boundaries, engineers, to go and help manifest that. And then maybe like 10, 20 years down the line, we'll all have a language for how we understand data science, and this will all be like a kind of non-problem, because we'll just be able to talk about it very easily and efficiently in an organizational sense. But we're just not there.
No, and to be fair, I don't think engineering is. I don't think computer science or computer engineering as a discipline is. It's still really in its infancy. I mean, you said as an engineer you can go and pick up an approach, but they don't tend to. It tends to be not invented here. We've got better with kind of package libraries and reuse and open source and things, but still developers' mindsets are often, I'm just going to write something from scratch. I think one of my hopes is, as we start to bring a more scientific element into technology, that people maybe start to think differently, and maybe the engineering and the science side start to collaborate a bit more. We do a bit more kind of progressive thinking, hopefully, to make the engineering better, which will in turn make the interface into science a bit better. But yeah, I agree. At the moment, it still feels like everything's kind of in its infancy, really, which is a little bit scary, a little bit.
Yeah. I mean, I think on that note, actually, I'll revise my estimate. Instead of 10 to 20 years, it'll probably be 100 to 200 years. That seems more reasonable.
Well, we've got the cloud now to do lots of processing, so everything's fast. Everything, all the time. And ChatGPT can obviously tell us the answers to everything we need to know anyway, so that's fine.